Okay, stuff out. Let's go. Hey, Drace. Your spot's up here. Your spot's up here. Yeah? Because that's where it always is. Come on, bud. Okay, that one checked in. That one's HOSA. That one's gone again. Okay. Oh, no. There, he exists. All right. No, Sean's here. Yeah, I don't know if he's going to be back, though, so don't take a spot. Don't take a spot.
Sit him next to me.
Well, that's a big no. So, we already went through the 4-3 stuff inside the packet, and then we had a little bit of extra stuff. Just wanted to practice some of these with fractions and big nasties and all that kind of business. On the front page, what were we doing? 6, 8, and 9? 6, 8, and 9? Okay. So, what we should have is -4w cubed. There's 1938 -35 plus 3w squared. There's 4w's, 15w's, 19w's. I know a bunch of us did this in class together, but I'll still write it. 6 and 4th, 5 minus 2n cubed minus 4n squared. Okay, first two, checky checky. Again, if you don't got the work to back it up, don't matter. Yes, ma'am.
We have to do fractions. Does that work?
They are all reducible fractions. You always got to reduce. Yeah, so like if you called this 18 thirds, always reduce. Okay. Do we need to go through either of them? Hearing no objections. And we also did, I believe, 9. Would have been 5, -10, 12, 2t squared. 5, -5, -14, -18, 22, 32. T plus 15.
How do you get 32?
Oh, that's plus. By doing mental math before lunch. -45, -18. So 5, -53, 63.
Is that a balance?
I risked it on mental math, yeah. Oh, all right. Be that way. Do we need to go through 9?
No.
I'll let Mom Bear know. You know what? As we're before I go on to the next page, though, just letting you know. Theoretically, you would get that your next class, which is Monday.
No.
So
6 inches?
put them together. That's 15 or 14 and climbing. But it won't be the whole month of June. Okay, so here's how this works. Spearfish School District has already surpassed the amount of days that are built into the school schedule past minimum contact hours set by law. Okay, we have 5 days past minimum contact hours required by law already built into the calendar every year. We've already had 6 days, which means we already have to do 1 extra day. For you, all that does is push your finals instead of Tuesday, Wednesday, Thursday. Now they're Wednesday, Thursday, Friday. No big deal. That changes things. That will do one of 2 things. Option A, they move all 3 final days to after Memorial Day. I've seen them do it. It's a possibility. So you would be here until June 1st. Option B, depending how bad that storm is, then schools would petition the governor to executive order forgive X amount of days. I've also seen that happen, where Miss Christie can just say, hey, y'all remember December when we shut down the state for 4 days? That don't count. I've seen that happen too. In which case, we would just go on business as usual. We would end on the 26th. It can be either one. I don't know. I'm just letting you know that's a thing. So I'll let Mama Bear know that, yeah, we're going to do brownies, but the question is whether you're going to get them on Monday or Wednesday. Okay? Just letting you know. Where are we at? We're on this one? Okay. Then flip it over to the back side. We're supposed to do another 3 back there. I don't remember which one. Someone help me out.
5, 6, and 8.
Okay, you should have a 4b squared negative 16 negative 10 b minus 24. You should have a 4x squared 8 18 negative 10 x minus 36. We should have a 10x squared negative 20 negative 30. No, that's an 8. Negative 18x plus 8. Check yourself. Check me, apparently. Do we need to go through any of them? I'd be happy to do whatever your preferred method is, too. You want a spaghetti monster, you want a box method, stack it, whatever your jam is. Foil. I know most of us in here are hypervisual, so probably going to gravitate more towards spaghetti monster and box method. Some people are super verbal, so they want to do foil. No? We good? Alrighty. Then, y'all owe me a daily check. Pow, 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 pow. Wait. 4-3. Multiply polynomials. I would like you to simplify both of these problems, por favor. this guy and this guy. Go! One is distribution. One is also distribution, but double. Okay. You do those two. Use the bathroom before we get started. And then it is time for a review and quiz.
Thank you.
What's up, sir? Do any of them have like terms? Same variable, same exponents. But they have to have the same variable with the same exponent.
Oh,
Okay. Mm-hmm. That is, I did 5 and 10. Everyone else did 6 and 9. 5, 8. So a lot of practice and time to work. Is anyone still going? It'll give us enough time. Okay. Still going? Okay. Suppose we can. That one's gone, that one's gone. Wait. That one's gone. That one definitely. All right. All right. So, if we're going to disturb it, really? You know, Frank, there's days. Just want to smack. There we go. Okay. If I'm going to distribute, I would strongly recommend that before I go distributing, I'm going to do something to indicate where my terms are, just so I don't screw up my signs. And then I'll take this times first term. Get negative 42, 7 by 6. M to the third and m to the first is m to the fourth. N to the first and n to the first is n to the second. If I do a negative 7 and negative 2, I get positive 14. M to the third, m to the first is still m to the fourth. N to the first, n to the fourth is now n to the fifth. And negative 7 by positive 8 is a negative 56. M to the third is lonely this time. N to the first and n to the second is n to the third. Am I allowed to put any of those together?
No.
They have to have not just the same variables, not just the same exponents, but the same exponents have to be on the same variables. So are there any other m to the fourth, n to the seconds?
No.
No. Any other m to the fourths, m to the fifths, any other m to the thirds, n to the thirds. So since there are no like terms, that's it. That's my answer. For this one, depends whether you were gonna box method, spaghetti monster, whatever your jam is. If I do, well, 3x times 5x, 3x times -1, forgot my squared there. If I do a positive 6 by a 5x, I'll get a positive 30x. If I do a positive 6 by a -1, I get -6. This is how I do mine in any of my upper classes. When I recognize a like term, I just kind of stagger them like this so that I can have my like terms already lined up for me. That's a 15x squared. 30 minus 3 is 27. -6. So, what I'm going to do is, we're just going to say, there's a lot of stuff going on in both places. I'm going to say 1 for numbers, 1 for variables and exponents. 1 for numbers, 1 for the correct variables and exponents. And then 1 for, I swear I did all of that correctly, but I said -3 times 30 for some reason, did -90. Or I got in my own head and for some reason thought 2 and 5 were the same thing. Maybe I just wrote one of them as a 2. So I combined them. Okay, so basically 2 each and 1 floating for a tiny whoopsie. Okay? Then, remember, if you're not sure about those, ask. All right, so we got more. We got more on here this time because taken individually, they're not terribly difficult, but there's a lot of moving parts. And what I wanted to do was give you a couple of opportunities at each skill. So like the adding and subtracting polynomials, I wanted to give you a couple versions of it because maybe you got the skill, you just brain farted the arithmetic. Okay? So we got a little more on here than usual. It's still our normal 36 for the test. It's going to be 6 for the completed review with work. I've been doing that this semester. And each of these is just going to be worth 3. Okay? So, first up, classifying by terms and degree. Y'all got your cute little cheater chart? Maybe you got it in a note card. Maybe it's written in your packet. All of our special names. I hope we got them written down. Okay, the general gist behind it was, if I go by degree versus I go by terms, if I've got 0, 1, 2, 3, 4, 5 plus okay. If something has 0 terms, you didn't write anything. So that one just doesn't apply. N/A means non-applicable. Means it doesn't count. This will not happen. It's not possible. That would literally be a blank problem. But if it's got 1 term, 1 mono term, nomial. Monomial. And then you just keep smacking different prefixes on there. 2 terms is binomial. 3 terms is trinomial. And at 4 plus, we could say quadrinomial, pentanomial, hexanomial. We could keep going, but at 4 plus, we're just going to say polynomial. Because polynomial covers everything. Okay? If I'm going to go by degree, and then an example of each might be helpful. If I just have the number 5, that is called constant. If I've got 3x, well, this is x to the first, so I call it linear. Remember, these are special names. If I have 1/2 x squared, if I've got a 2 up there, we called it a quadratic. If I got a 3 up there, that's a cubic. And I can't remember if I went to quartic or not.
Yeah.
We did do quartic? Okay. So if I got x to the 4th, it's quartic. And then after that, if I've got x to the n, we just say degree n. We just get lazy. Okay? So our first day was probably the easiest one. It was all about vocabulary. We wrote down our cute little chart, and then tell me, by degree, what's the biggest exponent you see in this thing? Well, remember, this is a coefficient. Invisa 1 is our exponent. So I go to degree, I go to 1, I say it's a linear. Then I go to, there's 2 terms. So 2 terms is a binomial. That's it. You call this thing a linear binomial. Okay, should feel an awful lot like biology, right? Your taxonomical classification. Okay, Canis Major. Wait, no, that's just the Big Dipper. I'm confusing biology with astronomy. Yeah. Okay, so the first 2 are, as long as you've got your cute little cheater chart here, you're good to go. Second one. Before I go naming it, are any of those able to combine? Remember, like terms have same variables and same exponents.
No.
They're all n's, but one's a 5, one's a 4, one's a 1, the other's a 7. None of them can go together, so no, I can't simplify it. Be careful about that. Write that as a note. If you can simplify it before naming it, it's kind of like you find some random chunk of like metal or something out in your yard. You're digging for a project. You're like, dude, what is this? I don't know. It's covered in mud. You might have to clean it up a little bit before you can tell what it is. You might have to simplify it before you can name it. Okay? Now, by, let's do terms. That's the easiest part. How many terms do I got? Every time we run into a plus or a minus, oh, I got to move that one. It's a new term, and there's 4 of them, so I'll call it a polynomial. But what kind of polynomial? Remember, the degree is the big dog. Who in there's got the biggest exponent? The 7th. That's the big dog. Be careful. You might see some like this that are out of order. This determines a degree. Do I have a special name for a 7th degree? So you just call it a degree 7 polynomial. That's it. Okay. You name it very lazily, like the people who were taking in immigrants at Ellis Island 120 years ago. They didn't know how to pronounce someone's name that was Czech or Swedish or something. So, what's your dad's name? Uh, John? Cool. You're now Johnson because you were John's son. Okay, that's why we have so many freaking Johnsons in this country. It's because of that. Okay, that was the naming convention for immigrants. It was very lazy.
In my family, we were Johansson, and then we got here and they said, nope, you're Johnson now.
Mm-hmm.
Okay.
Another one would be like they would use professions. Like, do you have know anyone whose last name is something like Mason? A mason is just someone who works with stone. They're like, well, I can't say your last name, so what do you do? I like make concrete steps and stuff for like buildings. Cool, you are now Mason. They would just rename them. Pretty messed up, right? Okay, the next 3 are combining like terms, and we want to be very, 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 very careful. You know what? Actually, I want to do 4 before this one. Because 4 says plus. If I just say thing plus thing, I don't have to worry about too much. I can just split up my terms, look for like terms. Remember that every time you run into a plus or a minus, it's a new term. So I hit a plus or a minus, 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 I hit a plus or a minus. I will tell you the number one thing that kids are going to screw up on this is the signs. It's not the arithmetic. It's not whether it's a like term. They're just going to screw up their signs. So please do boxes. If you were a fan of the like triangles and circles and stuff on like terms, PlayStation style, if you want to get some highlighters and do different colors for the different terms, you got to do something. Okay. So, contestant 1. Look for the big dog. Where in here do you see the biggest exponent? We like to put them first. Okay? Do I see any other 7x, or sorry, not 7, any other x to the thirds? No. So since I don't see any other x to the thirds, I just put him out front, scribble this out to say I'm done. Now look for the next biggest one, x squared. So I look for an x squared and I see a negative 8x squared here. I see a plus 9x squared here. So if I put those together, you owe me 8 and then you give me 9? Positive 1. And don't write the 1. because that's not as simplified as you can get, right? We don't need that invisible 1. Since this is 1x squared, we don't write that 1 normally, do we? If I said 3 minus x, do I write as 3 minus 1x? We might put the 1 there as we're working to help us, but it's not something we normally show. You just assume that it's there. Okay, we'll get rid of that. Boop. And do I see any, there's 3, there's 2, do I see any regular x?
Yeah.
This guy. Do we have any others?
No.
So he just gets thrown in there. We scribble that one out, and then as we're scribbling these out, we're also eliminating options. I only have a 4 and a 2 left. They are like terms, put them together. Okay? Double check before moving on to the next one. Are any of these like terms? Did I maybe goof?
No.
I got a bunch of x's, but a 3, a 2, a 1. They don't have the same exponents. I can't put them together. So what is different? Now we'll back up to number 3. What's different about 3? Oh, we had 2 parenthesis units on number 4.
We did? Oh, we did.
What's different about this that changes how I'm going to start? I saw like 2 of you do this. I got to distribute my negative. Okay? I don't want to screw up my signs. So the first thing I do is I see my invisible negative 1 here. I'm going to distribute that so I don't screw this up. I'll say negative 1 times negative x squared is plus x squared. Negative 1 times positive 3x is negative 3x. Negative 1 times negative 5 is plus 5. These guys, I'm just going to write them again so everything's on the same line. You don't have to, but I found that it keeps us from forgetting things if we keep everything on the same line. Okay, I took care of my negative. Now what?
Now you gotta smack them together.
Okay, whichever ones can go together, smack them together. And that's where I'm going to break out my chop, 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 chop. Every time I run into a plus or a minus, it's a new term. Interesting. And I ask, are there any, who's the big dog? X squared has the largest exponent. This does have the biggest coefficient, but we want the biggest exponents out front because remember order of operations? Exponents comes before multiplication. So I always want to deal with exponents first. So x squared goes out front. It didn't have any buddies to play with. Now what?
Now you put 7x.
Now deal with the x's. I have a 7x and a negative 3x that go together. 7x's minus 3x's is plus 4x's. Scribble them out. And then a 1 plus 5 is just plus 6. That's it. Okay, we spent like 2 days on this. I hope it's easy for us. If we're struggling a little bit, that's okay. If we're horribly lost, why weren't you asking questions the last like week and a half? Okay. And then what else? Number 5 is another simplify one. I want you to try this on your own right now. Just try it on your own. I'm still going through it, but test yourself. Do you got this? Do you need to distribute your negative or not? Make your boxes. Watch out what is a like term and what is not. Y'all would like my wife. I told her that y'all got brownies and she said, ha, get wrecked. So, yes, I do need to distribute first. That's a positive 2m squared. That's a negative 4m. This stuff just drops down. And then, everywhere there's a plus or a minus, chop it up. Look for the big one, the big exponent. M squared. I see 3m squareds and 2m squareds. Put them together, you got 5m squared. Be careful that your exponents don't change when you're adding. Then look for the next big exponent. In this case, it's just m to the first. 2m's minus 4m's. Scribble them out. And then, everybody hurts sometimes. That one is just there by himself at the end. Got no friends. Just gonna stand there and watch everyone awkwardly. Y'all feel confident about these? Like, if you watch out for your signs and you don't change the exponents, it should just be multiply and add, multiply and add, multiply and add. Okay. Then we moved on to distribution. Now we got to be careful about our exponents because they are going to change. I'd recommend the first thing to do on this, I would put my invisible ones up on exponent town whenever I need to. Because I've noticed a lot of us, if we have that invisible one there, we remember to add the exponents. But if we don't have that invisible one there, we forget. So that'd be a good idea. Next, everything in those parentheses, I'm going to chop up like this. So I know what I'm distributing into in terms of signs. So I don't goof my signs. And then, here we go. Take a negative 5x squared times a 3x squared. Number times number, turtle with turtle. Negative 15, and then x squared times x squared, you add together the exponents. 2x is here, 2x is here, x to the fourth. Go negative 5x squared times 9x to the first y. Yes, ma'am. I took negative 5 times 3. Caught up? Good? Okay. So when I multiply these two together, I want to do numbers with numbers. Negative 5 times 9 is negative 45. Now deal with the variables. X to the second with x to the first makes x to the third. Y is just y. It just gets smushed on the end. And then a negative 5 and a negative 8 is a positive 40. An x squared and a y squared. Do I like smash them together and call it xy to the fourth? It's just x squared next to y squared. They stand awkwardly next to each other. That's it. That's the answer. Done. Like, it's 3 points. I'm guessing it's probably going to be the 3 terms. Yay. Or maybe, depending how you did it, I might look at signs, numbers, and exponents. Okay? So that's just straight distribution. Then we started getting, man, that is some pixelated, like, 8-bit Mario crap right there. There you go. That's better. Okay, it's probably not bad on your paper, but you have choices. Option 1, the spaghetti monster. Oh, I also really recommend, some of us got better when we put mini boxes on these. Like this. Because I know some of us were goofing our signs on these still. The negative, right? The negative is the bane of the math student. But if we put the little boxes on there like this, some of us got a lot better with the signs. So what is an x times an x? Ooh, I heard 2x and x squared. Okay, when I multiply things together, exponents change. So that's x squared. If I do x times, now I know it's a positive x times a negative 3. So, negative 3x. And with the spaghetti monster, we'll distribute the first guy until we're all done. Then we move on to the second guy, and I'll just come underneath. I'll say negative 2 times x is a negative 2x. And a negative 2 times a negative 3. This is where we'd probably goof if we didn't have that box. Negative by negative. This is positive 6. Do I have any that I can combine? The x to the first and the x to the first. There's someone in the other class, I really liked how they did it. They chopped up with boxes, but then since they saw these two went together, they actually used arrows to show they go together. That's a negative 5x. And then they just drop these down. I thought that was a nice way to show it too, is literally the arrows. You can follow with your eyes where they came from. Okay, that's the spaghetti method. I know most of us were about that. Really? Some of us, on the other hand, screw you then. Go away. Go away, go away, go away, go away, go away, go away. All right. Some of us, on the other hand, would rather do an x and a negative 2, an x and a negative 3, like this. instead. I know yesterday with the other class, there was a couple of them that were a little iffy, and they were finally asking questions, and I had them just force them to do the box, and they're like, oh, do this way easier. Okay, that's your jam. Do it. X times x. X times -2. X times -3. And -3 times 2. Okay? And then you combine which ones go together. But you have to pick the method that works for you. Pick a method. What do you think? Try it. Like, try this one solo. You want to do the boxes. You want to do the spaghetti arrows. You want to stack them old school.
Like that?
You got it in here and in here.
Two.
Put those little invisible ones on there, and it'll probably fix that. Yeah. Okay. So yeah, you got your boxes, but here. So do this guy, then this guy.
Like that?
So what's 5 n's times 4 n's? Yeah, that's 20. But remember, that's also an n times an n. So you got 2 of them. N squared. There you go. 5n times -2. There you go. Then a 3 times a 4n. See how this was a positive and this was a positive. And then a 3 times a -2. Just -6, yep. And then do any of them go together?
Yeah. How'd you get x2?
Here, put your little invisible ones on here.
Oh.
N times n is n to the second.
Okay, and then we did. Do you put that into there too? Because you get 3 right there. So how do I get?
It's the first 2 in this butt cheek go to the second 2 in that butt cheek. So I'm not putting x to the -2 because they're
So
on
then
the same
you get 3
cheek.
then.
I said x times -3.
Why isn't that that?
Here, maybe it's because they're squished together. If I write it like x minus 2 times x minus 3.
Yeah, so that goes there and there. So that's
X squared?
X. So that's 2.
Yep, put your little invisible ones on there.
Yeah, and that's 2
X squared. X to the second.
squared.
No.
There's no.
Exponents change when multiplying. This is 1 times 1. X times x is x squared. 1 times 1 is just 1.
Okay. And then that's x times
So that's,
3.
think of it as 1x squared, like this.
Mm.
Exponents got their own laws. X times -3. Now come underneath. negative
Oh,
2
yeah.
times x. Negative 2 and negative 3 is positive 6.
Yeah, I just got confused because you switched the order of them. So like that doesn't go straight down. It goes like, and that doesn't go straight down here. It goes like over there.
And because multiplication is commutative, I've seen kids do x to this, 2 to that. Then underneath they do 2 to this, x to that. Yep, that works too. As long as both of these end up going to both of those eventually,
It doesn't matter.
the order won't matter.
Okay.
You should get the same
So that's
numbers.
that goes there.
Yeah?
12.
Work it out.
Okay. I really, really, really wish that more of us would be comfortable with that box, because I swear it would alleviate half of these problems. Okay. I usually do something different so I can differentiate where my problem is versus my answers. Because now all of your signs are taken care of. Maybe I go put my invisible ones on here and say 4n times 5n. Well, 4 and 5 is 20, n and n is n squared. 4n and 3, 4 and 3 makes 12. N is just n. Negative 2 by 5n, negative 10n. Negative 2, positive 3 makes negative 6. Then you just got to combine your like terms. Okay? You'll get the exact same things here if I do what I would recommend. Put your little invisible ones on here. Then say these boxes times these boxes, and then you go spaghetti monster on it. Now, Dylan had a good question about the order on this. Said, what if I did 5 times that guy and 3 times that guy? Then switch to 3 times that guy and 5 times that guy. Is 5 still going to both? 3 is still going to both. I'm going to get the same answer. Okay, you just did it in a different order. And that's totally cool. You'll get those same things, and we should end up with like terms on the diagonal, or if we're doing it this way, probably our like terms in the middle. 20n squared, but in the middle, negative 10n's and 12n's is plus 2n's. It's just finding the way to organize it that makes sense for you. Like, have you ever, you go over to someone else's house and see how they have their kitchen set up? And you just twitch a little bit? Because why would you put the bowls over there? That's not where bowls go. Obviously, the bowls go by the cups. And then it just starts arguments. I gave up on that argument about 15 years ago with my wife. I'm just not allowed to touch the kitchen. Okay? It's just your method of organization. What I do up here doesn't have to be the way you organize it. I'm just trying to show you different choices. Okay? And by the way, the silverware drawer always goes over by the microwave.
No.
So it's just right there. It's right there.
It goes by the
Fight you. Okay.
My
People about to start throwing hands. Okay. All right. And then we're going to go old school. We are not too far away from a final. So I want to go review some stuff. No. Do you remember if there's a 3 on the parentheses, who getting that 3? Everybody. Now, before I do that, I'm going to tell you, it's going to be very big and complicated if I do that first. I want to look inside the parentheses and see if I can simplify that at all. First up, these are regular numbers. Regular numbers can be reduced. So, do you know of a number that goes into both 60 and 36?
2. No.
Yeah? If I go 2, I'll get 30 and 15. 15. 18. There we go. Someone else said 6. Doesn't 6 still go in there? All right. I'll keep going. If a 2 and a 6 both went in there, couldn't I have just done it by 12? Ah, sneaky, sneaky. So, I'll have a 5 here and a 3 here. Do you remember what the rule was with negative exponents? Your 2 negative go downstairs. So I'll put this one here and this one here. Okay, so I kind of dealt with those. And there's my y's. Y2, Y, Invisi1. And I've still got my to the third to deal with. Okay, so I'm taking it a little bit of a piece at a time, right? You don't eat the entire sandwich at once. You can't Garfield like, ah. Okay, you're not a seagull. Take it a piece at a time. Take it a little bite at a time. We reduced a fraction and we moved our negative exponent. Okay, now blue stuff. What do I do with an exponent times an exponent? I add them together. So now I'm at 5 and 3 x to the 8th. What do I do with an exponent divided by an exponent? Oh, subtract. If multiplying exponents means add them, then dividing exponents means subtract them. Or do you remember the who's got more game? 2 minus 1 is 1. I got a y to the first up top. And then the whole thing gets thirded. Because it is all still to the third power. Y'all got a calculator? What's 5 to the third? It is a number.
It's 125.
Okay. Remember, you get a car, and you get a car, and you get a car, and you get a car. What is 3 to the third?
27.
What do I do with an exponent raised to an exponent? If this is add, what's exponent to an exponent? Now it's multiply. So 1 times 3 is 3. 8 times 3 is 24. Y'all, this problem is directly off of the review from quiz number 2. Like, beginning of October. Okay? Yes, it was a long time ago. That's why we're reviewing.
Wait. Thank you.
Well, the answer part's gone.
I'm writing notes to myself. So
Oh, okay.
Okay. Okay, hold on. Speed it up, Provence. I'm trying. Sullivan's eyes are getting hurry up.
CJ got the best grade out of everyone in both classes. I don't think y'all should tell her what to do.
Oh, 27. Okay, sorry. Okay, I'm hurrying.
Okay.
X. And then X to the
Third or x to the 24th, y to the third. Because it's 8 times 3 and 1 times 3.
X to the what? Sorry.
24th.
24. Thank you. Okay, there we go.
Okay. And then the last one, this is to the beginning of this semester, was compound inequalities. It's like a triple balance. What you do to one section, you do to all three. The whole thing's being divided by 4. I don't like that. So how do I undo divide by 4? Okay. So this times 4 is 12. This times 4 is negative 12. I still don't got k by itself. What's with it? Specifically, a positive 11. Well, there's a coefficient of 1 there, yes. You're right. So subtract 11 from all three parts. 12 minus 11 is 1. Negative 12 minus 11. You owe me 12. I let you borrow 11 more.
13.
You owe me 12. I let you borrow 11 more.
Why?
Negative
23.
23.
Good job.
And then, does it make sense to have a 1 on the left and a negative 23 on the right? To have the bigger number on the left and the smaller number on the right?
No.
Doesn't a number line normally go smallest to biggest?
Yeah.
So take the whole thing and set it back down. Make it look the way it's supposed to. Put negative 23 here, 1 here, k in the middle. Make sure Pac-Man is still eating the same numbers. It was eating k from the 23. It was eating 1 from the k. You literally just pick the whole thing up, turn it around. It asks for the graph. The graph is super simple. Do you remember more ink here, more ink here, less ink here, less ink there? K is between. My answer is between. Well, it's those exact same numbers. Negative 23 and 1. Okay. I'll tell you it's another and inequality like this. I didn't switch between and or. But we do need to start reviewing stuff like that before finals. Make sure you're 1 per table.